In this segment, we're going to work on reducing or simplifying rational expressions. First of all, you want to think of a rational expression as the quotient of two polynomials. What we're going to have is we're going to have some fractions set up, and we're going to try to reduce these like we would reduce a normal fraction. So for example, I have the fraction 6 over 8 up here, which we should be able to reduce by now. If you were thinking about reducing 6 over 8, you're going to break 6 up into its factors and say 6 could be 3 times 2. Over the factors of 8, we could break that up into 4 times 2. Now that we have it down to the product of their factors, now if they have a common factor, we could reduce it or cancel it. So we're saying here that since they both have a common factor of 2, we could cancel those out and leave 1s. It would leave us with 3 times 1 over 4 times 1, which would become 3 over 4. So in other words, if you're reducing 6 over 8, you reduce it down to 3 over 4 by canceling out common factors. But notice you couldn't cancel until you got it down to the product of common factors. So what we want to do with polynomials when you're simplifying rational expressions, fractions containing polynomials, is you want to break it up into their product of their factors and not reduce until you do that. So for example, if you had the polynomial 2x plus 10 over x plus 5, you want to look at each one first, and we want to try to factor them before we reduce, get it down to a product of factors. If you look at 2x plus 10, we have a greatest common factor up here that we could take out that would be a 2. We can't take anything else out because this one does not have an x. If you pull a 2 out, 2x take away 2 will leave you with x, plus 10 take away 2 or divide by 2, you get 5. Over, and your denominator is just like it is now. Can't do anything to x plus 5. So now that I have it down to a product of factors, I have it as 2 times x plus 5 over x plus 5, I can now cancel out that same factor. They both have an x plus 5. I can reduce them, so I'd have a resulting fraction of 2 over 1 or just 2. So I have simplified 2x plus 10 over x plus 5 down to 2. And what you want to think of when you're simplifying these is you're trying to make things easier. If I told you what x was, would you rather plug it in here and work it out? Or would you rather know that no matter what you do, if you plug it in there, your answer is going to be 2, okay? Another example, what if we had 2x minus 10 over 4x squared minus 20x? So again, we got a quotient of two polynomials. We can't start canceling until we get it down to a product of common factors, all right? So on top, if you look at top, you want to look at your numerator, 2x minus 10. What could we do here in terms of factoring? Well, they both have a greatest common factor of 2. If I take a 2 out, 2x take away 2 would leave me with an x, minus if I had 10 divided by 2, I'd get a 5. So I've broken up my numerator into a product of its common factors. Divided by on the bottom, I've got 4x squared minus 20x. We have another situation down here where you want to look for a greatest common factor first. If you look at 4 and 20, their greatest common factor would be 4. Both of these terms in our denominator do happen to have the letter x, or the variable x, so we want to try to take out the smallest exponent again, which would just be an x. So that would be our GCF down there. So if we do our 4x squared divided by 4x would just leave you with an x, minus, if you did 20x divided by 4x, that would just leave you with a 5. So now we have our numerator and our denominator down into a product of factors. So now we see if they have any common factors. The most obvious factor, I would think, would be these x minus 5s. We have two same binomials there, so we want to cancel them out. Whenever you cancel out, you want to leave yourself a 1 there in case nothing else is left. We do have one other thing here. Notice we did factor out a 2 and a 4, so we could reduce them by a factor of 2. So that would leave us with a 2 there. So now you want to look at what's left. On top, we just have 1 times 1, which would just be a 1. Over on the bottom, we have 2 times x times 1, which would just leave us to 2x. So there's your final answer there. So again, you have simplified things because you have taken, if you knew what x was, would you rather plug it into your original expression, or would you rather plug it into this expression down here? You want to think which one is easier. All right, one more. What if we had a rational expression that contained two trinomials that needed to be factored? If you remember, when we factor two trinomials, we're trying to find the product of two binomials that equal that trinomial. So what we want to do, we can't cancel yet until we get the product of common factors. So if you look at your numerator, we want to look at x squared minus 2x minus 15. We want to set up our two binomials. How would you get x squared? Both terms would have to be an x again. And then we want to think, what factors of 15 would add up to a 2? And since this last sign is minus, we want to have different signs down here. So the factors of 15 that would add up to 2 would again be 5 and 3. And then to add up to a negative 2, I would want to have a minus 5 and a plus 3. So we've broken up x squared minus 2x minus 15 into a product of its factors, which is x minus 5 times x plus 3. We want to do the same thing to our denominator. We're going to start by finding out the first term in each one. To get x squared, we must have x and x. Then we must figure out what factors of 6 would add up to 1. We do have a 1x right there. So the factors you would want there would be 3 and 2. And again, if this last sign right here is minus, we're going to have mixed signs down here. To add up to a positive 1 and multiply to get a positive 6, we would want a plus 3 and a minus 2. All right, now that we've got it down to this factor times this factor on top over this factor times this factor on bottom, now we're ready to finally reduce what we can. Since you have a product of factors, if you notice, they both have the factor x plus 3, so those can be canceled, and you're left with x minus 5 times 1, which is just x minus 5, over you have 1 times x minus 2, which is just x minus 2. So your simplified version of x squared minus 2x minus 15 over x squared plus x minus 6 would be x minus 5 over x minus 2. And you got to think of it this way. If you knew what x was, would you rather plug it in here and figure out, or would you rather plug it into your simplified, easier version to figure out?